China cuts ties with ASML and TSMC marks a turning point in chip sovereignty. China has officially severed procurement ties with Dutch lithography giant ASML and Taiwan's TSMC. On April 12, 2025, Beijing terminated all contracts involving ASML's lithography systems and TSMC's chip production for state-linked firms. Analysts at Bernstein have described this as the most significant shift in semiconductor sovereignty since 1987. This move followed a year-long acceleration of China's domestic semiconductor manufacturing capabilities. SMIC, China's leading foundry, doubled its DUV-based wafer output to over 300,000 wafers per month, compared to 2023, according to IC Insights. For ASML, this development is serious. The company earns nearly 70% of its gross margin from EUV machines, and UBS reports a 12% drop in advanced tool bookings from Asia in Q1 2025. TSMC now finds itself in a strategic bind. Its massive $100 billion US expansion, once celebrated as a geopolitical win for Washington, is now a liability. Beijing has blacklisted TSMC nodes above 7 nanometers. But the real surprise isn't just China's exit from the Western chip supply chain. It's how ready they seem to be and what they've built in its place. It's a shift that may render Western sanctions obsolete. Back in 2020, the US restricted Huawei's access to TSMC's advanced nodes and ASML's EUV systems. Credit Suisse later called this the most expensive forced innovation cycle in modern tech. 5 years later, Huawei and SMIC responded with the Mate 70 Pro, powered by a domestically produced 7-nanometer chip made using deep ultraviolet lithography and self-aligned quadruple patterning, SAQP. The chip used no foreign equipment or imported wafers. When analyzed by Tech Insights in February 2025, the chip showed a transistor density 17% below Apple's A17 Pro, yet it delivered comparable AI inference performance. Huawei then launched the Ascend 91C, a high-performance AI chip aimed at rivaling NVIDIA's H100. Mass production began in March 2025 at Huawei's Qingpu facility. Bloomberg reports that over 30 Chinese AI firms signed supply agreements in Q2 alone. This wasn't a stopgap, it was a strategic overhaul. If China's next steps succeed, the country won't just be catching up, it may actually be changing the direction of the semiconductor race. China's quiet attempt to reach 3-nanometer production without EUV has divided experts. TrendForce argues that without EUV, the complexity of multi-patterning makes 3-nanometer yield rates commercially unsustainable. Yet leaked data from a SMIC prototype wafer in April 2025 revealed critical dimension shrinkage to 34-nanometer gates, close to 3 nanometers, using quadruple patterning. Yes, costs and production times have surged, and yields are hovering around 40% per IC Lab Asia. But China isn't trying to match Western benchmarks of efficiency. It's focused on scale and resilience. With state subsidies covering losses and guaranteed demand from defense and AI sectors, SMIC's approach may not make sense economically, but it is geopolitically calculated. Morgan Stanley's March report warns that China no longer needs to match TSMC's cost efficiency. It just needs to scale a viable alternative faster than the West can restrict it. After NVIDIA exited the Chinese AI market in late 2024 due to US chip bans, a $7 billion market gap emerged. Huawei filled it quickly. In May 2025, Huawei began mass shipping the Ascend 910C, built by combining two 910B dies in a 2.5D package to challenge NVIDIA's tensor processing power. While not a 5-nanometer monolithic breakthrough, it achieved 75% of the H100's performance at just 55% of the cost, according to China AI Tech Watch. Huawei's initial chip batch sold out to state-backed cloud firms in just 11 days. Even more telling, SMIC's DUV-based production line, using adjusted SAQP techniques, achieved a 56% yield by mid-May, up from 31% in January. It's not technical parity, it's strategic asymmetry. Huawei doesn't need to beat NVIDIA on every metric. It just needs to deliver good enough chips on time. This is the new front line in the global AI race, and it's not in Silicon Valley anymore. By Q2 2025, over 82% of the components in China's sub-10 nanometer chip supply chain were domestically sourced, according to the China Semiconductor Industry Association. SEMICA's new megafab in Shenzhen, completed in just 16 months, is now producing 45,000 wafers per month in the 7 nanometer and 5 nanometer classes. Meanwhile, Shanghai Microelectronics Equipment, SMEE, reached its first production run of 28 nanometer capable steppers in March and aims to hit 14 nanometers by the end of 2026. On the talent front, over 1,500 engineers from TSMC and UMC have reportedly joined mainland Chinese firms since 2022, drawn by compensation packages averaging more than double their previous salaries. According to Nikkei Asia, China's $47 billion semiconductor fund was restructured in 2024 to focus on vertical integration, prioritizing domestic self-reliance over global collaboration. Unlike ASML, which depends on Carl Zeiss optics and German photonics for key components, China's chip ecosystem is advancing, slowly but steadily, toward full independence. If current trends hold, the biggest threat to Western chip dominance won't be espionage or IP theft. It'll be strategic redundancy. In February 2025, a leaked document from China's State Key Laboratory of Laser Technology shocked the industry. It outlined a prototype for a laser-induced discharge plasma, LDP, EUV source, promising 90% lower power consumption than ASML's current laser-produced plasma systems. According to the E-Journal of Photonics, this design replaces ASML's inefficient twin-laser tin droplet system with less than 0.1% energy conversion efficiency, with a dual-stage system using a low-power ionizing laser followed by a high-current discharge. Engineers at Applied Optics Beijing claim early lab tests have already generated EUV light at the key 13.5 nanometer wavelength, achieving 0.8% efficiency, 8 times better than current Western systems. Of course, lab success doesn't guarantee high-volume manufacturability, but if this new approach can scale, it would eliminate the need for ASML's 170 million euros EUV machines, which currently require more than 1 megawatt of power each. This isn't just technological catch-up, it's a redefinition of the rules, and the West may no longer be the one writing them. One leak, one shockwave. Is China about to break ASML's EUV monopoly? One leak changed the global investment landscape. But let's step back for a second. How close is China really to turning its EUV blueprint into a working machine? ASML's dominance in EUV lithography is built on a system that, frankly, consumes more energy than it produces in output. According to the International Energy Agency, a single EUV production line running at full capacity draws as much power as 1,200 average American homes per month. That's because ASML's laser-produced plasma, LPP method, requires 50,000 laser pulses per second. It also demands massive heat management systems and complex mirror arrays that degrade after only 20,000 wafers. Compare that to China's proposed LDP, or laser-induced discharge plasma, method, which bypasses tin vaporization entirely. Instead, it creates a stable plasma using electrical discharge, producing EUV light with significantly lower thermal loads. Chen Wei, a former Zeiss SMT engineer now consulting for Asia Lith, told Bloomberg in March that if China can scale this at an industrial level, it would upend the energy-to-precision trade-off that's defined chip making for over 15 years. ASML declined to comment, but the signs are telling. In April, the company cut its 2025 EUV shipment forecast by 18%, citing regional procurement uncertainties. Quietly, ASML has started redesigning its next-generation source architecture. Why? Because the threat isn't hypothetical anymore. TSMC's Arizona fab isn't just costly, it's now geopolitically exposed. With $6 billion in US subsidies and production agreements tied to national security clauses, TSMC is now obligated to prioritize Washington's interests over market-driven logic. ASML, for its part, is squeezed from all sides. Its core optics rely on German export licenses and Japanese photonics, while it's caught between Dutch regulatory oversight, US political pressure, and shrinking demand from Asian clients. TrendForce reports that TSMC's foundry utilization rate dropped to 76% in Q1 2025, down from 89% a year ago, largely due to cancelled orders from Chinese customers. Meanwhile, Canon's FPA1200NZ2C, a newly commercialized DUV system, is gaining traction as a neutral, non-aligned alternative. In just 5 months, it shipped 27 units across Southeast Asia. ASML's dominance isn't gone, but its moat is rapidly drying up. The biggest problem isn't just that China left the table, it's that others are starting to take its seat. Still, building an EUV system is a far cry from running one at scale. Producing 30,000 wafers per month at 95% uptime is a bar few can reach. China's LDP project still faces significant engineering hurdles. One of the biggest? The extreme reflectivity mirrors needed for EUV, which contain over 100 alternating layers of molybdenum and silicon, and must maintain defect tolerances below 0.2 nanometers. Tokyo Electron executives told Nikkei Asia in April 2025 that China's domestic metrology tools still can't achieve the sub-angstrom precision required for mask alignment. On the materials front, Chinese photoresist makers like Giwa Chemical have yet to deliver polymers that meet the strict yield consistency needed for full-scale EUV production. Even if China cracks the light source, synchronizing the entire chip production process, etching, deposition, inspection, remains a major integration challenge. That said, China's commitment is undeniable. The State Council recently allocated $9.3 billion to fund 4 pilot production lines. As Bernstein tech strategist Lisa Chow put it, China has proof of concept. What it doesn't have yet is repeatability under pressure. But that can change fast. Just ask anyone who thought Huawei couldn't make a 7-nanometer chip. So, here's the real question. If China successfully cuts the cord from ASML and TSMC and builds something leaner, cheaper, and more energy efficient, what does that do to the global tech stack? Think about it. Every AI server, every quantum simulator, every military targeting system in the next decade will depend on who controls the light source. Today, ASML controls that light. But what happens if Beijing breaks the bulb? The blueprint is just the first crack. The next move? It's already being manufactured, behind closed doors. So let me leave you with this. If China renders EUV obsolete, who gets to rewrite the rules of war, wealth, and power?
如果您有其他主题想深入了解的话，欢迎留言告诉我们。您的意见对我们来说非常重要。